Hello everyone and welcome to this tutorial. In this video I will give you a short introduction on how to set up the new anode overhang analysis. Here you can see the scan of a battery showing the battery's casing, the anode, and the cathodes. What we want to do in this example is to measure the anode overhang using the new battery analysis. Therefore, we first have to create regions of interest for the anodes and cathodes. You can do this using any segmentation tool at your disposal. However, we are going to use the new Paint and Segment tool to create a quick and easy segmentation. For this purpose, we have already created a segmentation model. If you don't know how to use the Paint and Segment tool, feel free to check out our dedicated Paint and Segment tutorial. Now, what I will do is to click the Apply Paint and Segment Model button in the Select ribbon, then make sure my model is selected, and activate the preview. I'll have one last look to make sure everything looks good. What you can see is that I have used one class for the anode, one class for the cathode, and one background class for all the rest, including the casing. After verifying the preview, I will click Create Rows to apply the segmentation. As you can see in the scene tree, I have a region of interest selected. This region of interest contains a slab around the slice that is currently visible. This will run the segmentation only on this region of interest, making it faster to compute. Since the battery analysis works in 2D, this is completely sufficient for this use case. Now that we have the rows for anode and cathode, we can create the battery anode overhang analysis. So, I'm going to select the volume, switch to the analysis ribbon, and click the corresponding button. This then creates a new analysis instance, and now we have to fill in some settings. First, I'm going to set the analysis plane to front 1. I use upside down because my anode overhang is at the bottom of slice, not at the top. If it were at the top, I'd have to use front 1 instead. Next, I'm going to select my anode row and my cathode row. And with that, everything is set up. All that's left to do is to look at the preview and check that the endpoints of the anodes and cathodes have been correctly identified. Since I find 2 stragglers that I want to get rid of, I set Remove Particles to 1500 voxels. Now that this looks good, I am going to hit Calculate. After the analysis has been calculated, the results are visualized in the viewport. We can see a zigzag line connecting the anode and cathode endpoints. This line can be used to easily verify that the order of the anodes and cathodes has been detected correctly. On top of that, we can also see a color overlay. This color overlay can be used to visualize the various measures the analysis output. Per default, it is set to the left projected overhang. Other results include the shape following overhang, the max, curvature, the adjacent cathode count, the exit angle, and the average thickness. And with that, I think you know everything you need to know to get started with the battery anode overhang analysis. Feel free to check it out, and until next time.